The quotient rule of exponents allows us to simplify expressions that divides two numbers with the same base but different exponents. So for example, if we wanted to um, consider something like y to the ninth divided by y to the fifth, notice that the numerator and the denominator have the same base. So the the quotient rule of exponent says that we can subtract those exponents from the numerator and the denominator, and that leaves us with y to the fourth power. So why don't we take a look at a couple of examples together. Let's consider s to the 75th power divided by s to the 68th power. Because we have the same base here, we can subtract the exponents, so that's s to the 75th power minus 68, leaving us with s to the 7th power. Let's take a look at another example. Let's simplify -3 to the 6th power divided by -3. So here, let's focus on the numerator. Anytime that you have a negative number raised to a power and that power is an even power or an even exponent, then that's going to result in a positive value, okay? Because here you can think of it as, I'll write it off to the side here, -3 times -3 times -3 times -3 times -3 times -3, 1, 2, 3, 4, 5, 6. So here we've got these two negative numbers. When we multiply them, it's going to be positive. All right, these two negative numbers, when we multiply them, will be positive, and then these two negative numbers, when we multiply them, are going to be positive. So the ending result is going to be a positive number. Okay, so that's always going to be true when you've got a negative number raised to an even power. So I'll write here that it gives us +3 to the 6th power. Now notice the denominator is still -3. So you can think of that as -3 to the 1st power. So if I have a positive divided by negative, that's going to result in a negative number. And here I can apply the quotient rule to 3 to the 6th divided by 3 to the 1st, which is 3 to the 6th minus 1. So final answer is -3 to the 5th power. Okay? All right, let's consider an example where, let's say I've got -3, but let's say it's to the 5th power divided by -3. So here, because I have a negative number raised to an odd power or an odd exponent, okay, the final answer or the result of that is going to be a negative number, okay? So here I would have -3 to the 5th power divided by -3 to the 1st. And then here, because I've got a negative divided by negative, that's going to result in a positive number. So I've got +3, and here we can apply the quotient rule to the 5th minus 1, which is 3 to the 4th, +3 to the 4th power. Okay, let's take a look at one more example. In this example, we're going to use the quotient rule, but we'll also take a look at the power rule. So let's call this example D. Let's suppose we have E times F to the 2nd power raised to the 5th power divided by E times F to the 2nd power raised that to the 3rd power. So let's just focus on the numerator for right now. Notice that in the numerator you have an exponent. That's, you can think of that as e to the 1st times f to the 2nd. So we've got an exponent, and that's being raised to a power. We can simplify this by using the power rule, and the power rule says that you simply just multiply the exponents together. So e to the 1st, you can think of that as e to the 1st raised to the 5th power, which is the same thing as e to the 1st times 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 e to the 1st, so 5 times, which is the same thing as e to the 5th power. And then you've got f to the 2nd power 5 times. So that's f to the 2nd power times 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 f to the 2nd power, which hopefully you guys would all agree with me that this whole thing is the same as f to the 2nd times 5 power, which is the same thing as f to the 10th power, right? So anytime you've got something like this is where you apply the power rule. I would apply that exponent to each of the terms in the numerator there, and by multiplying the exponents together, okay? So let me just rewrite this off to the right-hand side here. That we get e to the 5th times f to the 2 times 5, okay? And then the denominator, we would do the same thing. Apply the power rule, right? Distribute that to each term there. And so we've got e to the third power times f to the second power times third power. So this gives us e to the fifth times f to the 10th divided by e to the third times f to the sixth. And then now we can apply that quotient rule. E to the 5 minus 3 times f to the 10 minus 6, resulting in e to the second power times f to the fourth power.